Okay, so the next type of problem is division. And this works much like multiplication, except we're going to use keep, change, flip. So we're going to keep the first fraction. We're going to change the division to a multiplication, and we're going to flip the second fraction, meaning we're going to change places for the numerator and the denominator. We're going to turn it upside down. So that gives us 3x plus 3 over x plus 2 multiplied by x minus 1 over x squared minus 1, because we've flipped this one upside down. All right, then it works just like multiplication. We are going to have to factor some things. We're going to need to factor this 3x plus 3 and this x squared minus 1. So 3x plus 3, we have a 3 in common as a GCF, so we're going to pull out a 3, and we've got 3x plus 1 over x plus 2, just sticking in parentheses because we always like to stick our binomials in parentheses, times x minus 1 on top, and on bottom we're going to have a difference of squares. We've got x squared minus 1. That x squared is a perfect square, so is 1, and has a minus sign. We can also think of this as x squared plus 0x minus 1. So we can think about pairs of numbers that multiply to give you -1 and add to give you 0. And that, of course, is 1 and -1. So either way you think about it, difference of squares or traditional factoring, you're going to wind up with x plus 1, x minus 1. All right. Now we're ready to simplify. So we're going to cancel out anything that's the same on the top and the bottom, on the numerator and the denominator. So we have an x plus 1 in both places. We also have an x minus 1 in both places. That leaves us with 3 on top and x plus 2 in the denominator. Let me shift the paper slightly, just so we can continue to see what is happening here. Okay, so we've got that. That is part of our answer. But we have to consider domain restrictions. Now, for domain restrictions, we know we need to consider anything that's in the denominator. But we have to think about anything that has ever been in the denominator. So, of course, we have this, and we have this, and this. Those are all in the denominator. But this x plus or x minus 1 used to be in the denominator right here. At the very beginning, it was in the denominator. So because we flipped that second fraction, we have to consider the denominator and the numerator of the second fraction. In this case, that x minus 1 is in both places, so it's not going to make a difference. But you always have to remember for a division problem to check the denominator of the first fraction and the entire second fraction. All right, so let's just list what we've got. We've got an x plus 2. That, of course, can't equal 0, or we have a divide by 0 error. So we've got that. We've got our x plus 1 not equal to 0. And then x minus 1, we have a couple different places, but we only need to list it once. All right, we solve each one of those. First one we solve by subtracting 2, so we get x not equal to -2. This one we subtract 1, so we get x not equal to -1. And this one we add 1, so we get x not equal to +1. So our domain restrictions summarized are x not equal to -2, -1, and 1, which is also part of our answer. We're really not done until we've done the domain restrictions, so I boxed that up as well.